Hi everyone, welcome back to Pine Hollow Auto Diagnostics. Today we got a big beefy PowerStroke 2014 F350 here. Customer complaint, power locks don't work. Initially he told me the unlock was fine and the lock didn't work, but now the door locks are just completely dead. He said there is a blown fuse. He tried replacing it. As soon as you hit the lock or unlock button, it blew. So that's the customer complaint. We have a great direction. Let's do the standard procedure, scan it for codes, and do some homework. So on the Think tool, we have the health report, and I don't see any codes relating to the locks in particular. There's some missing COM codes, but you know, the truck starts and runs and there's no warning lights. I tried all the buttons and the key fob. So, you know, you press the fob and the lights flash and the horn chirps, but the locks are just dead in the water. So let's get a wiring diagram for these locks, see how they're controlled and what the issue could be. Alright, did some homework and printed off a wiring diagram for these door lock actuators. So fairly straightforward. This is the body control module. They have internal non-serviceable relays. That's great. 20 amp fuse. So I assume that's the fuse that he was talking about, and that feeds power to the load side of these relays. And how does this work? So the left front, the driver's door lock actuator, has a separate relay, driver door unlock relay. So when you hit the fob just once, it'll just unlock the driver's door. So this will switch over, send current here, and the return path is through this other relay to ground. And in default, this is also grounded. So this master relay, it's the all lock or unlock relay, and as you can see, if you send power to pin 31, it'll unlock the other three doors, the passenger doors. That's this relay clicking like this. Okay, and the current path returns through here. If you want to lock all the doors, then this switch flips over, click, and sends power to here to all the locks this way now, and they return through this close contact to ground. So classic door lock diagram. Let's find this fuse, F20 20 amp in the BCM. I printed off a picture of the BCM. So fuse 20 is going to be right there. Let's see if we can find it. Alright, so the BCM lives over here, and this cover, fuse 20, is right there above this relay. And what I'm seeing is there's a 20 amp and then there's a blank slot. So perhaps the owner took out the blown fuse. So let's put in a 5 amp test light in here, try to activate the locks, and see if there's a short to ground. Alright, so got the test light pair installed. So I'm using the 5 amp setting, which means both bulbs, both filaments, all in parallel. Let's see what happens when we hit the lock button. Oh. Unlock. Okay. So the relay's buzzing because, why is it buzzing? Well, check this out. So we're doing a maximum of 5 amps through here, and if there's not enough current, the control side will also lose voltage. Alright, so the whole downstream of this fuse, or my test light, the voltage will drop because there's a short somewhere, I assume, in the load side, and then the relays will buzz. Okay, that makes sense. So how do we track this short to ground? Let's try again. mean, it's a 20 amp fuse. We can put an extra, we can put more test lights on there. But you know, 5 amps is a good number. That should be able to activate the door locks. We can even listen. Let's do it this way. We can unplug this connector C2280D. We know what pins are going to each lock. So for example, if we send 5 amps down this way and the driver's door unlocks, then we know the short's not here. If we send 5 volts down this way and all the doors unlock, we know the short isn't in here, maybe it's in this tree. If we send 5 amps this way and all the doors lock fine, then we know the short isn't in this tree, it's somewhere here. So we can pinpoint this by doing manual checks, bypass checks at this connector. Let's find these wires and print off the pinouts of this connector. So pins 26, 21, and 31. Let's go find it. Alright, here we go. So I got the connector C2280D unplugged and took the cover off, located our 3 control wires for the door locks. So we have the purple and gray, the blue with a green stripe, and then the gray with a brown stripe. So we have access to all 3 pins. Now let's do some bypass tests. Let's start with the blue and green, so pin 21. Basically I'm going to send power to here, and if there's a short circuit here, our test light will light brightly. If there's a short circuit somewhere else, then the actual driver's door lock should unlock or activate. Let's try that. So 5 amp test light directly from battery power through an adapter. So pin 21 is going to be the blue and green. That would be this pin right here. Okay, you hear that? It's trying to unlock. What if we push the button down? Will that pop up? That's this pin right here. Let's look at the button. Yes, easily. And the test lights aren't even thinking about lighting. So perfect. So we just checked through here, through this actuator, nothing's shorted, but there's a short somewhere from this tree to ground, because if we unplug this, everything's good, and we send power here, it would have nowhere to go. It couldn't complete a circuit. Okay? So let's send power to pin 26 or 31. So 26 is the gray and brown. That would be over here. Double check, yep. So right here, look at that. Short circuit. Door locks aren't even trying to activate. And then let's try pins 31. That's the all or passenger unlock. Violet and gray. That's this one right here. Also short circuit. Huh. But then again, keep in mind there's 3 actuators on these circuits, so I don't know if 5 amps is enough. We could try to run a little bit higher current. Because what are the chances that there's a short circuit to ground and on both sides? That's not very likely. Alright, so one more trick here is to get an ammeter out and just put it around the test light control wire. So when I energize the driver's lock, the unlock button, let's see what happens. About 1.7 amps. Okay, so each one of these actuators draws almost 2 amps. So if we're trying to drive 3 actuators, that's going to be close to 5 amps. So I'm going to try the all lock, 4.7, and all passengers unlock 4.5. Okay. So these three all unlock 4.5. Over here 4.7. And why is there more current? A little bit, like 0.2 amps going this way. That's a direct short to ground versus this way. So let's look at the ammeter again. I'm going to touch this to a known good, solid ground on my lead. Try that again. 4.7, all lock. 4.7, all unlock. 4.5. Interesting. Definitely a direct short to ground somewhere, but it's still not conclusive if it's here or here. How do we track this down? Well, Ford is actually nice enough that the connector for each door is easy to unplug from the body. So if that's easy to do, why not do that? So unplug the right front door, and is the short in the body somewhere or in the doors? So we have to figure that out. So basically, right front, we just unplugged the S655, so this is out of the picture. Let's do the same test. So all lock, still short at the ground. All unlock, still short at the ground. Okay, let's do the next door. Alright, so I unplugged the driver's door, so now this is out of the picture. Lock, short at the ground. Unlock, short at the ground. The rear doors are not as easy to unplug because the pass-through, I don't know where the actual connector is. It must be in the body here. Let me try to get this off, see if we can get that unplugged. Alright, it's nice of Ford to give you a little access panel, and sure enough the connector is right here for the right rear door. Let's repeat the experiment. Alright, so all lock, still short at the ground. All unlock, still short at the ground. That's crazy. Let's unplug the last door. I'm trying to unplug this connector and it's not coming out. Guys, what do you guys see? Da, da, da. Uh-oh, we got some meltage. We got some meltage, and what wire is that? That would be our... Oh god, yep, that's it. The wires are melted together. Melted together. So, I'm going to take a picture of this for the owner. We're going to separate the wires out. Do a repair, maybe wrap these up. Why the heck did it melt like that? I have no idea. The harness just goes up there. It looks like it got really high. Continuous 20 amps up until the fuse blew, I guess. That's it. We're basically done. Alright, well this is really not good because the meltage keeps going up the harness. And the wires could be touching in other places. This is really not good. Now what melted to what? Well, there's the power lock wire, the all unlock. And that's melted to this pin, which we can't even tell the color of it. So let me separate these out, see what we're dealing with. So really, really not good. The meltage extends all the way down into the main harness. Oh no. You can see just bare copper. These wires are fused together. I'm surprised the truck didn't have more problems than this. Holy crap. Alright, so my question is, how did a fuse not prevent this total disaster? It's complete carnage. So how many wires do we have to deal with here? 1, 2, 3, 4, 5, 6, 7. Looks like 14 wires. The fatter ones actually survived, these 4. Where do all these wires go to? So the ones that survived, like this yellow one, power window switch. So the fatter ones are okay, 1, 8, 7, and 14. Again, power window switch, so that I think is still okay. And then, well, 14 is the all lock wire, which is this gray and brown, which looks like got really hot. But the one that's completely unrecognizable, the one next to it, pin 13, is the violet and gray, the passenger door unlock wire. So violet and gray going to the left rear door. This right here is burnt up. So why did that happen? Let's check if the door lock actuator on the rear left, if that's, you know, still working. So these are the 2 pins, and I have a test light hooked up, 5 amp test light, and it's open circuit right now. So if I hook up the test light, you know, right to ground, I know I have a good power and ground, but yeah, that might have been the initial problem. The door lock actuator shorted in this door and then caused an overcurrent situation where, you know, that relay closed and then just straight current went through, and this wire is thinner than this one because it's only designed to drive one door lock, and that's it, game over. Now why didn't that just pop a fuse and not melt the entire thing? I don't understand, because these circuits are only energized for like a second or two. Doesn't make any sense to me. You know, the relays work fine. So what do we do? Do we just tear the door apart and just tell the customer this door won't lock or unlock? He probably wants it to work. So I really don't know what the best solution here is. And then the harness, well, it's going to take hours to repair it. I don't know if the meltage goes further down along the entire truck. That's the entire cab harness. That's like, you might as well buy a new truck. So, yeah, kind of not a good situation. I'll talk it over with the customer, see what they want to do. So my goal right now is to get rid of the short. You know, how far does this meltage go? Pretty far. So I'm trying to separate the door lock wires and just cut it off somewhere here, so we're eliminating this shorted mess, and see if the other door locks come back online, and then you know, this door just might be disabled for life. Yeah, this is bad news. So I'm measuring for short to ground going that way, shorted to ground, and shorted to ground. So both wires are still shorted to ground. Going that way in the harness. Unfortunate. So we can take off this plastic, maybe find them right here, see where the meltage stops, and then just snip them, and disable that, you know, disable the short circuit. The stuff doesn't look terrible here. Let me find those wires, and we'll cut them somewhere right here.